So then the second concept that we need is the ideal gas law. And what the ideal gas law does, so what we find here about the ideal gas law is that this law describes how a simple gas behaves in terms of three parameters. And these parameters, as we will find here, is the one here is the number of molecules. Two, it turns out to be the temperature of the gas. And three, how big the volume is. The volume of the container. And the ideal gas law, we can write it out somewhat, but again, it's a very, very simple model. Like if you tried to get numbers out of the ideal gas law, you wouldn't be very successful. But this is essentially what the ideal gas law says. So the ideal gas law reads like this. So if I look at the gas pressure, is proportional to, so it's going to be proportional to what? The number of molecules times the temperature of the gas divided by the volume of the container. This is the ideal gas law right here. And you'll see that this is very, very intuitive. And the way I'm going to do this here is that I'm going to show this to you through an applet, because it's extremely, extremely powerful. And the applet essentially looks something like this. And here's sort of like a big image of it, but I think it's going to tell us, a couple of things. So we just have a few minutes, so I won't go into too many details here, but check this out. What you're going to find here is that this guy right here, this guy is a pump. So this pump, what it does here is it tells us about the number of gas molecules. And what you're going to find here is that this guy over here is our thermometer, right? This is our thermometer. And our thermometer reads temperature. So that just tells us about the temperature, but it's this guy over here though. This guy right here tells us about hot and cold. So this adds heat, I should be careful, adds/removes heat. which then implies it changes temperature. So when I say collisions, what do I really mean by collisions? So collisions, so when I say the word collisions, we got to be really, really careful. So collisions of gas particles are only with the walls of the container. And it's this collision, this is what creates pressure. So when I say the word temperature, what do I mean by temperature? Well, temperature is the average kinetic energy of the gas molecules or the gas particles. So there's a difference between the particles colliding with the walls, and then you can have particles that collide with each other. So temperature is the average kinetic energy of the things. And we should say here is that collisions between particles are effectively ignored, and they don't contribute to the temperature and they don't contribute to the pressure. Well, that's a white lie. And that's what we mean by a very, very simple law when we say this here. So we've talked about a couple of things. Let me find my mouse again. So we've talked about the thermometer. So the thermometer measures the average kinetic energy of the particles. So in other words, we could say here is that if we have a lower kinetic energy, then this implies a lower temperature. If I have a higher kinetic energy, then I have a higher temperature. And so if I go back up here, so if we're adding heat, that means we're increasing the average kinetic energy. If I take heat away, that means I lower the average kinetic energy. And the thermometer is a direct measurement of this thing. Temperature, which I'm going to say is proportional to the average kinetic energy of gas particles. Now, the pump here then determines the number of gas molecules. So if I pump it in, then that allows me to do that. So another thing that we should really look at right here is that note that this right here is the walls of the container. And you could clearly see that there's walls all the way around, right? We could come all the way around and you could see that these are the walls. So any surface that a gas molecule collides with is then going to create that pressure. And the last thing that we got to talk about is we got to talk about this handle here. Now what this handle does here is that this handle, what it does here is it changes volume. So if I pull it out, I get a bigger volume. If I push it in, I get a smaller volume. And so how we measure pressure now is then going to be by this pressure gauge. And that's going to tell us. Now, we could measure this pressure in atmospheres, or we could measure it in pascals.